Hello everyone. In continuation to our topic maintenance management, this is question number 9. Indian Electronics manufactures TV sets and carries out the picture tube testing for 2000 hours. A sample of 100 tubes was put through this quality test, during which 2 tubes failed. So from this we can say the total test time. The total test time is 100 tubes multiplied by 2000 hours per tube. So that works out to 2 lakh hours. Now they say in this 2 tubes failed, but we don't know whether it failed in the beginning or in the end. So we'll be assuming that it is failed in between, means these 2 tubes which have failed it is not specified whether it failed in the beginning or in the end. Hence, we will assume that it failed in the middle. Therefore, the last hours is equal to 2 tubes. Each tube is going to take 2000 hours for testing, but we are considering that it failed in between, so 2000 by 2. So that works out to 2000 hours only. Means the last hours is 2000 hours. Therefore, hence, the used hours is, we will consider the total hours of testing, which is 2 lakh hours, less last hours, which is 2000. So used hours is 1,98,000 hours. Now, further what it says, if the average usage of TV by the customer is 4 hours per day, and if 10,000 TV sets were sold, then in 1 year, how many tubes were expected to fail? And what is the mean time between failures for these tubes? Okay. So, given 2 failures in the above 1,98,000 used hours, hence for 4 hours per day, with 365 days per year, and 10,000 TV sets. That is for, let us multiply this 4 into 365 into 10,000. We will get 146 lakhs hours used. The failures will be 2 divided by 198,000 multiplied by 146 5 zeros. So that will give you 147.47, which is approximated to 148 tubes. Now, mean time between failure will be the 198,000 divided by 2 failures. So we get 99,000 hours per failure. We can also convert this into years by considering 99,000 hours per failure divided by 4 hours per day into 365 days per year. That if we calculate, we will land up with 67.81 years per failure. So that will be the solution for this particular question. In this, we will understand some of the maintenance related measures or metrics. One is MTBF, which we already seen in the previous problem, how it is measured. We need to know how many hours of the are used, and then number of failures. That will give you the mean time between failures. So since it is mean time between failures, higher is the better, means higher MTBF is always considered to be better for a particular machine or a particular product. We can also call this MTBF as measure of reliability. Another one, MTTR, mean time to repair. How to calculate that? Hours taken in repairing divided by number of failures or repairs. So since it is related to repairing time, lower MTTR is considered to be better for any specific machine or for any specific product. This MTTR is also called measure of maintainability. Then we have the third measure, which is availability ratio, that is calculated as hours used divided by the total time available. Total time available means hours used plus hours taken for repairing. That will come in the denominator. So if the hours are known, we will use the first formula, but we don't know hours, but we have MTBF and MTTR, then we can use this as MTBF divided by MTBF plus MTTR. If we can check this, I mean this, if I substitute this formula, and then for these two, if I substitute the formula, number of failures will be there both in numerator and denominator, which we will cancel. And then you will get to arrive at the same result, what is given here. So higher availability ratio is always considered to be better. Based on this understanding, let us do a numerical question. Product A has MTBF of 30 hours and has a MTTR of 5 hours. Product B has MTBF of 40 hours and has a MTTR of 2 hours. Which product has the higher reliability? Which product has greater maintainability? Which product has greater availability? So let us do one by one. The first one, MTBF. Since they are talking about reliability in the first part, we are considering MTBF of A is given as 30 hours. And then MTBF of product B is given as 40 hours. So this is lesser. So whichever has the higher MTBF, that is more reliable. Therefore, product B has higher reliability. Second part, maintainability. So we'll consider MTTR of product A is given as 5 hours and MTTR of product B is considered as 2 hours. This is larger. Therefore, we can say so maintainability, whichever is got a lesser MTTR, that is better. So here again, product B has greater maintainability. Then third one, let us calculate availability of product A and availability of product B. Is MTBF of product A divided by MTBF plus MTTR of product A. So that is 30 divided by 30 plus 5, which we will get 30 divided by 35. That is 5 6 or 5 7s or 6 by 7 is working out to 0.86. Now let us calculate availability of product B. Availability for product B. So even here I will change the wordings to for. MTBF of B divided by MTBF plus MTTR of product B. MTBF of product B is 40 divided by 40 plus 2. Which is 40 by 42, or we can write 2 20s are 2 21s are. If we calculate, we will get 0.95. So since availability of product B, which is 0.95, is greater than availability product A. Which we calculated as 0.86. We can conclude product B as greater availability. So that is the solution for this question.